good day, everybody. I'm Andra Keay. I am absolutely delighted to be at my first FIRE event. I have been following it from afar, and I am passionate about the intersection of robots and society. And just to give you a quick background, I'm the child of an astrophysicist and a science fiction nerd. So naturally, I grew up wanting to be an astronaut. But beyond that, I wanted to be the first person to interact with aliens. And partway during my life, possibly after I had my first child, I realized that the aliens were already among us in many ways, but that it was robotics. And this robotics and AI was actually our first intersection with alien technology. And we have everything in the world to learn about how to interact with robots as they are becoming more and more sophisticated. And I am absolutely delighted to be joined on stage by three of the founders of the world's most advanced robotics. Absolutely. We have Jonathan Hurst, who is the co-founder and chief robotics officer of Agility Robotics. We have Bernt, Børnich, who is the CEO and co-founder of 1X, which some of you may have known previously as Halliday Robotics. And we have Jeff Cardenas, who is the CEO and co-founder of Apptronik and has been working a lot with NASA. Now, actually, Jonathan, can you describe, and can we roll the film for Agility Robotics? Can you describe a little bit about the Agility Robotics humanoid called Digit that we're seeing here?
Sure, glad to. So I like to think of these as human-centric robots in that the entire purpose is to build robots that can go where people go, can do some basic human workflows, can work with and around people, and primarily exist and coexist in human environments and human spaces. And they end up looking a little bit humanoid, but of course that's not the goal in and of itself. It's human-centric. Now, because it's human-centric like that, it can be multi-purpose, because there are so many tasks that have been kind of tailored for us, for our workflows, for our environments are engineered for us, doorways and hallways and stairs and everything else. So having a robot that can go where we go and interact in that kind of environment means it's going to be able to do a whole bunch of different tasks. And we start out, like in this video, doing something fairly simple. And it's something that is very process automated. It's very, very repetitive. It's just picking up a tote and moving it to a conveyor belt, or picking it up off of another mobile robot like an AMR and putting it on the shelf. Just pick up a tote, carry it somewhere, and set it down. So it's a really good, call it a beachhead market. The first thing that it does, the first narrow class of tasks for these human-centric robots.
Bernt, can you tell us a bit about Eve and how Eve differs from Digit and what the capabilities of your humanoid robot are?
Sure. So,
and I think,
maybe
we can end this video now. Yep. Thanks.
Start a bit with, so Eve is very manipulation-centric. So it has the full capability to use both arms, 7 degrees of freedom, same as us, and a bit less focus on the mobility side. We kind of started in opposite ends. So Eve is used currently in warehouse logistics, and then it's also used in guarding of enterprise facilities.
So indoor security for commercial enterprises.
Yes. But of course, most of our company currently is working on our next android called Neo, which is very different from Eve. So Neo is only about 30 kilograms, and it's 165 centimeters tall. So that's about the average height of a human. It has the same range of motion as we do. It has full dexterous hands, and it can lift about 75 kilograms in a deadlift or a squat. But I just want to highlight what really puts Neo apart from other humanoid robotics is that it's not really an industrial machine, like Jonathan here is talking about. It's actually kind of more like a Baymax. It's soft, like us. It's light and inherently safe. There's no pinch points or other, say, hazards. And we really hope this will allow us to pursue our vision of deploying safe and useful androids into consumer. So it's a pretty orthogonal market in that sense. But we do operate in logistics, et cetera, because it's very good beachhead markets.
there is a huge demand in the logistics industry, but you're both developing collaborative robots, as in able to work alongside people or safely work around people. And Jeff, would you like to say a little bit about Apptronik and what might separate the robot that you're working on from the Eve and Neo and Digit?
Yeah, certainly. So our robot is called Apollo. It's the 8th iteration of humanoids that we've worked on at Apptronik. We've done quite a bit of research and development and kind of the core building blocks of how you build an affordable and capable humanoid robot. The reason it's called Apollo is our roots at Apptronik started working with NASA. So 2 of our co-founders were working with NASA Johnson Space Center during something called the DARPA Robotics Challenge and helped build a robot called Valkyrie. And so we started working with NASA and we've continued to work with them today. But Apollo is really designed to be an industrial humanoid. So we do have long-term ambitions, and I think the dream is the consumer robot, but really focused on sort of utility in the early days. And I think a lot of folks here, we can talk about maybe why that is, are focused on these supply chain and logistics tasks in terms of what they do. The way that I kind of think about this for people that aren't sort of immersed in robotics is what I think humanoids represents is kind of this personal computer inflection point in the robotics industry. I kind of think of traditional industrial robots kind of like mainframe computers, and where we're at is building these more generalizable platforms where we can use software to extend the range of things that they can do. And so that's ultimately the ambition for us at Apptronik. We want to build the most useful tools that we can for humans, and so this is why the humanoid shape is so that it can work in the environments that we're living and working in today, and integrate seamlessly, and we can communicate with them and all the rest. And we can dive in more to that as it makes sense.
Yeah.
Why today? Because honestly, we've been dreaming about humanoid robots for a very, very long time. And all of a sudden, I'm tracking 16 humanoid robot companies. And by the end of the year, it's going to be 25 because China's just announced a 2-year plan to be mass manufacturing humanoids by 2025. So all of a sudden, humanoid robotics companies have hit stride, pardon the pun. What technologies have made this possible right now? Jonathan?
Well, I actually think there's 3 core reasons. There's core science, there's technology, and there's societal need and societal recognition of it. So in the core science, like Bernt said, we started in the locomotion, figuring out how to make a robot that can go where people go. And we've seen a lot of robots throughout the last 30, 40 years that can put one foot in front of another on flat ground and for a video camera, et cetera. But what we haven't seen is a robot that can really walk and run and jump and skip and hop and do all of the things that a person would do outside and everything else. Now, it was only in maybe the early or mid 2000s, like 2005, something like that, a couple of papers came out that even said, hey, this model for running applies to walking as well. This is a unified model. And it's just amazing that some of the basic science about biomechanics, about how animals move, wasn't even really well understood until fairly recently. Then there's, the power electronics going from these giant bricks down to these little things, and, actuators and sensors and things becoming more available so that you can assemble robots from it. And then COVID, right? Everybody
Yes.
all of a sudden says, actually, I do want robots to help us out. And that really changed people's attitudes, yeah.
And I think, Bernt, you've got a particularly novel way of looking at some of the internal technologies of your robots. Is that something that is really propelling you forward now? What are the technological kind of drivers?
Yeah, sure. So we have some pretty exciting advances that have been done on basically the power density of motors and actuators. And this allows us to back to the looking at nature, right? Taking more of a bio-inspired approach. So we actually have tendons that pull the joints inside the android to make motion. It's kind of like loosely inspired by human muscle. It's not muscle, it's like we're very loosely inspired. But what it does is that actually it allows us to mimic these adaptability and softness that you have in human motion. And this is immensely powerful when you want to go out in, like Jonathan said, like in unstructured environments, right? Like typical stiff old robots that you will really impact the ground. That only works if you know exactly where the ground is. The same goes for manipulation, right? We humans don't work like that. We're just masters of adapting to the environment. So I think that's one side of it. These things are becoming machines that are actually able to not only, I'd say, mimic human kinematics, like what's the joint pattern we can move in, but also actually the dynamics of how we move. Now, to the other side of that, then you get to the AI, right? And we finally now have visibility on how can we do end-to-end learning for embodied AI, where it's just all about the data, cloning human thought, cloning human action. And there's an enormous amount of engineering left to do there, but we're generally seeing that like it's now about how do you collect data at scale, how do you scale your models, and those two things come together, and then you have something that's really exciting.
Okay, we'll dive a little more into that aspect of it. Jeff, would you like to talk about what is the technology breakthroughs that are enabling Apptronik today?
Yeah, I mean, I think it's along the same lines that what both Jonathan and Bernt talked about. The way I kind of think about it, you can continue to use maybe this personal computer analogy, and the way I think about where we're at is maybe in the early 80s. This is the beginning. You can do your taxes. This is like logistics, right? We can do the first sort of applications. I think the interesting thing about why now is the technology is meeting this threshold sort of moment where it's now good enough to start to do useful things. But I think Jonathan alluded to this. The interesting thing is really the pull from the market. So one of the things that I sort of tell a lot of folks is there's not a demand problem for humanoids. The demand is massive. And I think the reason is a little bit interesting there is that it's clear that we have this big labor shortage. We have millions of jobs that we're short all across the U.S. specifically, particularly in industries like the supply chain and logistics. And it's clear maybe to many that automation is part of the solution. But actually one of the drivers for things like humanoids is out of the folks that have adopted a lot of automation today, right? So they've bought a lot of special purpose robots that just do one thing. And so the world is littered today with, thousands of different robots that just do one thing. And what the market is now really demanding is more versatility. Like, hey, can we get a robot to do 2 or 3 things? And so sort of the way that we're building up, and I think Jonathan talks about this well, is like we go from special purpose robots that do one thing to multi-purpose robots. So the threshold actually for the market is not a robot that can do everything, that can learn. This is where we're going. But actually the threshold for the market is really like, can you do something in the morning, something at lunch, and something by evening? And that becomes really exciting. And I think if you want a robot that can retrofit into an existing workflow designed around humans, then the humanoid makes a lot of sense. And so I think that's really been, in addition to the technology, a tailwind for the market as a whole.
Actually, can we continue just a little bit, Jeff, with your work, particularly with NASA as well? I know that all robotics companies use AI in some parts of what they do. Where do you use AI? What changes have generative AI brought, and where wouldn't you use AI?
Yeah, so I think some of the folks on the stage might have a more depth here, just in terms of the way that we've looked at AI today. The simple way of sort of thinking about AI is, in robotics, in my view, is you can put it in 2 buckets: physical intelligence and cognitive intelligence. And it gets, you can break that down further. There's many aspects to human intelligence if you're trying to recreate that in a machine. And what we've largely focused on, to date has been the physical intelligence side. How do you get a robot to balance? How do you get to move around the world? And you could call that AI, but a lot of that's more, in robotics, we call that controls. So we've really focused on kind of building from the bottom up. And I think a lot of the new cognitive stuff that's out there, while it holds great promise, it's still very early. It's still very unproven. And so for us, as we start to deploy these robots out into the world, what a lot of folks ask is like, where's the science experiments left here? And I would say that it's very unexplored on the cognitive side, but there's a lot of things that we can do with just machine learning. So one of the things that I explain to customers a lot is think of a humanoid today really in these first applications like a systems integration of things that you already see out in the world. So you have collaborative robots. These are human-safe robots. They entered the scene in maybe 2004. By 2010, we started to get compute that was good enough and started to get things like SLAM, the ability for a robot to navigate. So we got mobile robots. And then 2015 or so, we started to get machine learning, intelligent picking robots. you're kind of putting all of those aspects together in the first wave of these applications, which in my opinion is why, you know, logistics makes a ton of sense. You can do things, what I call gross material handling. You're grabbing something with 2 hands or grabbing something with 1 hand. And that's compared to maybe on the other end of the spectrum, you have dexterous manipulation and fine dexterity, which is a very difficult problem. So we've really started there, and we're basically using machine learning, reinforcement learning for these initial applications. But we are really excited about the new stuff that's coming out, and I think we're trying to be mindful, and that's more a question, is like, where should you use this and where shouldn't you use this? And that's a question for us to try to understand that better as we move ahead, understand what the real capabilities are. I think it's exciting to think about the new types of interfaces for how you can communicate with a robot as well as kind of a first step, but I'd be interested in the other folks.
Yeah, it's interesting. I think the 3 of us have actually slightly differing philosophies about where we start.
Yeah, so I'd say like we have probably a very contrarian bet here.
Yeah.
So for us, there's basically almost no classical control left. There's just everything is learned end to end. Mm-hmm. And that means for us, it's all about using data, right? So there's not a single line of code left now that's like task specific or market specific. Everything is just data. Yep. And then it's about how do you gather this data at scale? And how do you get to what I'd call like internet scale data?
It's very multimodal data, right?
Oh, yeah.
So it's not just a video. You have to collect the data of the forces and the acceleration.
Oh, yeah. Everything.
All of the sensor data. And
so like there. Quickly the way the system works, so we actually have about 40 robots now in operation every day doing data collection. Some at customer sites, most in like our studio where we're doing this. Then there's actually a VR system where you map the human's body to the robot, and then you do all of these very diverse tasks through expert demonstrations, and you can clone that. And then you have a reinforcement learning step before, right? And it gets very similar to how you think about like language models, where you kind of have both sides of it, and you need to align this. But then, very interesting, you talked about like the new things coming out, right? We have a pretty deep collaboration with OpenAI, and we are using GPT-4 with video to decompose these like long-term tasks into simpler tasks. So like tidy the table, and then you get a very good task description of everything you should do to do that. And then our embodied layer can kind of like take over, clone how that is done through humans, and do those tasks. But it's still early, and we need way more data.
Behavioral cloning is just starting to take off, as are 3-dimensional modeling and large multimodal systems as opposed to large language models. And this is where I find generative AI researchers look at robotics as this is the source of all the next interesting data. This is real world data. This is 3-dimensional data. And so I'm glad that you're able to really go out there on the edge of understanding this 3-dimensional world modeling. And Jonathan, I know you've also displayed some work with Digit using generative AI. Would you like to explain some of that?
Sure. So one thing I want to say is when people say we're using AI for our robots, it's like saying we're using math for our robots. Like AI is such a big umbrella, and it covers so many different aspects. And maybe it's like excludes some of the classical controls and things like that. Our approach is very much every tool in the toolbox, right? We use a lot of reinforcement learning techniques, a lot of generative AI techniques, and so on, use all the tools. And sort of to Jeff's point of the physical intelligence and the cognitive intelligence or the semantic intelligence, it's like the generative AIs will give you the IKEA instructions to do something. The physical intelligence will actually execute those instructions in the real world, turn the screwdriver, and so on. And so we've demonstrated kind of both sides of that. We've demonstrated, a completely learned policy for our early product, Cassie, like running a 100-meter dash and got the Guinness World Record for the fastest 100-meter dash out of a robot. And we could not do that with classical controls techniques. There were 10 of these robots distributed to universities for 5 years before a learned policy was able to achieve that kind of a performance and a behavior, because it's the first time somebody's actually done that kind of thing. So all of the tools together, it's really valuable.
And I just want to have like a small insertion on that, because I think it's very interesting. And like one of the main reasons, and in fact it's a bit contrarian, but like one of the main reasons that we are so bullish on targeting consumer and like layering services to be able to do that is actually the diversity of the data. Because we see this enormous improvement now in performance on our models when we train on like this enormous amount of different tasks, huge diversity. And then we're training on very narrow tasks like pick and place in logistics or these kind of things. Actually, to get really good at pick and place in logistics, you should have trained on like cleaning someone's kitchen, because like you get a better world understanding. And like seeing the signs of life that like these big data sets that are diverse actually improve narrow performance. I think that's a very interesting observation.
But you could only do this on a humanoid.
Of course.
Because it takes the human context and the human knowledge and our context that can apply directly to a machine. That's pretty unique for a humanoid robot.
And also, I think the only way you can solve the catch-22 of data here is to have a humanoid so that you can very effectively serve labor teleop-wise through the robot. Because in the beginning, when you do this, everything is not working. And you need to actually get to like trillions of these tokens for actions, embodied actions. And that's a really catch-22, right? Your product doesn't work day one. So really being able to efficiently serve labor through teleop and these expert demonstrations, it's a very interesting path.
This is well known in robotics circles, but not necessarily publicly. But many autonomous robots are teleoperated. They are not operating autonomously, or at least not operating autonomously all the time. So there is usually always humans in the loop in some fashion. And actually reflecting on how humans are in the loop, could you just each explain how you see the relationship between humanoids and humans going forward? Jeff.
So we come from the Human-Centered Robotics Lab. That's what we spun out of at the University of Texas. And, you know, my take is that, I mean, everything we've tried to do is to build the most useful thing we can for humans. Humans are tool makers. I think there's a big question of like, why do this? Why focus on this problem? Why do we need robots? And this gets very kind of existential to me, which is, it's really about time, right? Our time here is limited. And if we can build for ourselves machines that can do things that we don't want to do, well, then I think that frees us up to spend time the way we want. And I think that while you need to be careful about how that's applied, I think that could be incredibly optimistic. To date, you know, robots have been these lifeless industrial machines. And it's funny to be on a stage with other humanoid companies and to talk about 16 humanoid companies that are emerging, because I joke often that the only thing that people told us that was consistent when we started was like, don't do humanoids. They're too complicated. It's a waste of time.
It is easier to make money making an app.
Yeah,
I've woken up many times thinking that.
Well, and that's why I respect the people on the stage, is because you couldn't have done this long if you were motivated by money, because it was not an obvious sort of thing to do. But I'll let everybody else talk, but I think the idea is to build something that interacts with us, that can move in the spaces that we move in, that can communicate in ways that we're familiar with, and that we can build trust with to move into the future. And I think at some point there will be more robots than humans. I think if you look at sort of density, it's kind of tracking. We saw like we're kind of in the mainframe era, and I think there's going to be millions and billions of these things, and you have to think about what you want them to be like and what we want our interactions to be. And I think the folks here on the stage are really thinking a lot about that.
Yeah.
And it's not necessarily going to be as frightening. For example, there are more than 50 million Roombas in the world since 2005. That's gone up in quite an exponential curve. They are now 30% of all vacuum cleaner sales is the category of robot vacuum cleaner. And none of us are really scared of our Roombas, because they are simply a product that works well, that is convenient for us. Yeah. And so I do think that's a really positive example of what it takes to get a robot really deployed in the world, is meeting that kind of bar of product reliability and usefulness. But Bernt, please tell us about how your robots interact with humans.
Sure, so I think we're very much in agreement. I think what's really the focus for us that has been from day one, like 9 years ago, by developing the technology, is safety. I think the biggest barrier to entry, and where it really forks from more industrial applications, which are going to be incredibly useful and where we need all of this labor, is safety. And that's not something you can put in post. It has to be part of your design from the beginning. That being said, I think adoption rates, there's going to be billions of robots, right? And I think really what we're betting on here is the adoption rate of consumer, because it is so fast compared to everything else. And then there's a general tendency that things then trickle down into the industries, because now it's become so cheap, so reliable, all of these things. And yeah, this like future where you see like robots and humans live together and do tasks together, kind of like your personal assistants. Like, why should your personal assistant just be digital? Like, why shouldn't it be physical, right? And I think there's so many things there that are starting to work that actually that's the problem you solve first. And then the big danger here is becoming a gimmick, right? So like, really make sure you're solving some essential needs for the people you're helping, or it quickly kind of like just goes down again.
The safety is hard, right? Because the robots, in order to operate in the world, you said lift 75 kilos. That's a lot of force. You know?
But the force isn't really what's dangerous, right? It's the inertia, or like it's the kinetic energy in the end.
Depends on how the force and how much force and where it's applied. It's just a challenging process.
It's a very challenging process, but you can say generally humans are extremely safe. It's very rare that humans bump into each other by accident in the hallway and it's like catastrophic result.
And that's where the intelligence comes into play, right? So like the
Yeah, but it's
safety
passive, right? It's not about intelligence at that point. It's the dynamics of the human body being very low energy, soft, compliant, pretty
that's
lightweight.
Part of it. It's just obviously
it's a huge part of it. And of course there's safety layers.
Yeah.
And I'm not saying we're not working on the safety layers. There needs to be like as much as you can do, right?
An
but
example
I think you need to start.
Is like if you try to hit your hard stop, you know, basically hit your hard stop by hyperextending your elbow, your brain will not allow it. Your brain will, you know, activate muscles to decelerate your arm before you actually hit something physical. So there's like a lot of active stuff going on as well. And generally safety things are about like e-stops, which doesn't work for a humanoid. Robots, when they fall, you know, can cause problems. So, you know, going through, you're right, starting from the beginning with safety, thinking that through very carefully, that's one of the big things. You asked about like the, you know, the vision for how robots interact with people. I'll just add to this, the same things that they've said. The whole vision of agility robotics is enable humans to be more human. That's the vision. And that means robots doing things humans might not like to do.
I have a list.
I have one quick point to add. I thought Jonathan made an interesting point, which is just about culture and how culture sort of views robotics. And if you look at the way that they view robots in Japan or, you know, other Asian countries relative to the way that we view robotics in the West, it's very different. People are excited by them. They want them yesterday. Even robots with very limited functionality, they feel excited to be around. And in the West, we have a very different sort of fear, I think, that underlies the idea of robotics. And I think that's something that, for us to remain competitive, sort of, you know, as we move ahead, is going to be something for us all to think about how we move towards, because it's going to be important for us to embrace it as we move forward.
That's wonderful. And just before we have to break, I know people might have questions, but with so little time and so much to cover, we are all here for the breakout session at 4 o'clock. So there will be a lot of great question answer time. And I really hope that you all bring your questions. Just one final question though. Bernt, is it true you have your own humanoid android at home?
It is, and it's been interesting. I like to say that it's very soon having net zero contribution, but don't ask my wife. And it's a bit like having a child. So there's these strange noises at night, and you're like, oh, what happened? And you get up and you clean up. Oh man, are we learning a lot. And it's actually pretty humbling when you start doing this and you realize like how hard all of these tasks are. And it's not that we didn't do these tasks in a lab with like a mock-up kitchen and all these things. But like once you go into a home and you try to solve a real problem, and this is with Eve, by the way, the current Android we have. So like, but the goal here is to make sure that we really figure out all the hard problems so that Neo can actually do these tasks. And what really still amazes me to this day is like how almost any task you do in a home as a human, you don't do with your hands while walking around, you do it with your entire body, right? You're like leaning your knees on the lower cabinet while leaning over to get into the cabinet, or like leaning on the table while stretching out under the couch to like get that toy, or like humans' ability to have like this tiny footprint. We take so little space as we shuffle between the couch and the table and still be like super strong to do all these useful tasks. That's pretty unique even in nature. And that's, so a lot of hard work left to do.
And we learn so much about humans and humanity by studying robots. That is the most fascinating thing I have found as well. And I really want to thank our incredibly expert panel here of humanoid robots that you will all be seeing shortly. Please bring your questions to the breakout session. Thank you.
Thank you.